Hey guys, it's day 7 of 100 Days of DSA Challenge, and today we are back with the question Monk and Power of Time. So, with this question, we will now focus more on the Q-based questions since for the last 1 week we were doing stacks. Okay, so what does the question say? Let's not read this Monk aspect, let's just get straight to the question. Basically, you are given two things the calling. Okay, so you are given n number of processes and each process has a unique ID from 1 to n. Okay, so basically if it's written in input 1, if it's written 3, it means process ID 3. This means process ID 1, this means process with ID 3, this means process with ID 2. Okay, got that part. Now what we are given, we are given a calling order in which the processes are called, and then we are given an ideal order in which the processes must have been executed. So basically, this is the number of processes. This is the ideal order in which this is the calling order in which they are being called, and this is the ideal order in which they should be executed. So what we are what the condition is that a process can only be executed when it matches the order of the ideal order. Okay, so this is the calling order. Okay, so this means according to the calling order, process 3 is being called first. But what we are given is that process 1 should be called first. So it will what will it check? It will check, is this process 1? No, it is not process 1. So I can just shift it to the back. And then this will become the first element. Is this process 1? No, it's not. I'll shift it to the back. Is this process 1? Yes, it is process 1. So I will execute it. I'll show it better on the whiteboard on the next slide, but this is the gist of it. And what we have to return is the total time taken. Basically, our time will be taken on in two things, okay? Executing a process and changing the position. So basically, when the first element of this matches the first element of this, then we execute the process, and that takes 1 unit of time. And if it does not match, then what are we doing? We are shifting it to the back, and that takes 1 unit of time too. Okay, so we have to return the total unit of time, which we have to return the total time taken to execute all the processes. All right. So now let's see a test case. So this is the test case, okay? So let's see how it will work. It will first check that I have to execute one first, okay? This is the ideal order. Is this one? Is this one? No, this is not one. So I can shift it back and pop it out of here. So now this is 3. This is the new calling order. So now it will check the first element of this calling order. Is this one? No, it is not one. I'll simply pop. And guys, notice that it is given that every time we are either changing position or we are executing the process, we are increasing the time by 1. Okay, so execution of each process takes 1 unit of time, and shifting of each position takes 1 unit of time. Okay, so now what did we do? We shifted 3, so that took 1 unit of time. Then we shifted 2. Okay, we are shifting 2. So now it took another unit of time, and now it will check with 1. Is 1 equal to this? Yes, it is. So now they will be executed. This process will be executed. Now it will check. Okay, process executed, time increased. Is 3, is this 3? Yes, it is. Execute. Add the time. Is this 2? I mean, yeah, it is 2. They are matching. Execute. And now it took 5 minutes of time. So this was a test case given here, and that is the sample output. I hope you got the question. And now this is a very simple question, guys. So maybe you got the gist of it. What I told there is actually the solution. We just have to code this. And how can we code this? We can use queue. So each of these calling order can be considered a queue. Like calling order and ideal order can be considered a queue. So this is 3, this is 2, this is 1. This is the ideal order. And ideal, I mean, this is the ideal order which I'm writing right now, 1 3 2. So I can basically see ki if ith element of this queue is equal to, I mean the front element of this queue. Okay, you cannot random access a queue. So if the front element of this queue, so there is no I basically, if the front element of this is equal to the front element of this, then pop it. Otherwise what will we do? We will shift the top element of calling order to the back of the queue, and we will pop the queues from the front. Okay, So now this is the new, we will keep repeating this and so on. Okay, so now just let's get to the code. So in Hacker Earth, you are not given the input code, like you are given on lead code. So I was basically given nothing. I had to include this queue and I had to write all of this. This is all just to input. Okay, this part is for input. You can see it. It's easy. This is where the actual coding begins, the logic. So we are taking count. We have to return count, guys. Remember that count is the time which is taken, the total number of time. So now I'm saying that while calling order dot empty. Okay, so the calling order queue, while it is not empty, I will execute the queue. I will execute the logic. Why is that? You can see that this logic will be executed until the calling order queue is empty. Because when the calling order queue is empty, it means that all the elements from it were popped out, and that means that all the processes were executed, right? So that is why we are writing this statement, this one. And what am I saying? If calling order front is equal to the ideal orders front, as I said, okay, if they are equal, then I'll pop both of them and I'll say count plus plus. This means that successfully executed. This is the test case for successfully executed. Successfully executed. And else, what does else mean? Else mean that the process order does not match. Hence, what am I doing? I am calling order is the queue. I am pushing calling orders front into it. What does that mean? So you see, this was the front. This was the front. I am pushing its front into the queue. And you know, queue is FIFO. So if I am popping something, then the element pops only from the front, and if I am pushing something, then I can only push it in the back. Hence, I am pushing the front of the queue in its back. It means that I'm shifting the top element of the queue into the back of the queue. Okay, so that is what the statement means. And then I'm popping the element. I'm popping the top element after pushing it into the back, and simply count plus plus, and we print count, and that's it. That's how this code works. This was a very simple question, and I did this question to start with the queue, because I've been doing stack for a week, so I want to focus on queue based questions now. And yeah, guys, let's see you on day 8.